This is screencast number 1 for Module 7, Lesson 3. We're looking at linear inequalities in two variables. That's a fancy way of saying, hey, instead of an equal sign for our y equals mx plus b, we're going to have an inequality sign instead. Okay? A linear inequality in two variables can be written in one of the following forms. This is basically standard form, okay? The way they've written it. But you can have ax plus by is less than c, less than or equal to c, greater than or equal to c, greater than c. Okay, and not all the ones that they give you are going to be ax plus by equals c. As you can tell, very quickly, we go from what looks like standard form into something that looks like slope-intercept form. And the only difference, again, is that instead of an equal sign, we now have an inequality sign. And that's going to matter after we figure out where the line is and plot it. Okay? All right, so the first thing I want you to know is that if it's a greater than or equal to or a less than or equal to sign, when you draw the line, you will draw a solid line because points on the line will make this equation true because it says or equal to. If it's just a greater than or equal, if it's just a greater than or a less than sign, and there's no or equal to part, then the line that you plot should be dashed to indicate that the points on the line do not make the statement true. Okay, so that's a lot of words. Let me show you what I would like for you to write down. Okay, greater than or equal to or less than or equal to, your graph line will be solid because the points on the line make the inequality true. For instance, we take this inequality, graph it. The y-intercept is 6, and I'm going to go down 3 and over 5. I'm going to draw my line. My line will be solid, and the reason why it's solid is because it says greater than or equal to. Okay, then the one step that we are basically adding that we haven't learned, well, there's one step like, do I decide whether it's solid or dashed? But then, because it's an inequality, I have to decide which side of the line I'm going to shade. Because one whole set of points is going to make the equation true, and a whole other set of points will not make the equation true. So what I've done here, okay, after I graphed the line and I put it as a solid line because it says or equal to, is I picked two test points, one on one side of the line, one on the other side of the line. And I plugged in those x and y values into my equation. The blue dot, when all was said and done and I did all the math, says 0 is greater than or equal to 6, which is not a true statement. Okay. Down here, I put in the point 6, 6. And when I got that, it does say 6 is greater than or equal to this negative number plus 6. So I know that these two things together are going to be less than 6. So this side is greater than this side. Okay. And I don't really need to add these together necessarily to figure out that when I do combine them, they're going to be less than 6. So because it's this point that makes the equation or the inequality true, I'm going to shade that side of the line because any point on this side of the line is going to make the equation true. Any point on this side of the line will make the equation not true. Okay? All right. So pause if you need to, just to make sure that you've got all of this written down and you've done the little example. Okay, the part of the coordinate plane containing the solution set to the inequality, which may include the line, is called a half plane. So this is the half plane that makes the inequality true. All right, I'm going to move down. I used a little bit of real estate down at the bottom to write my other statement that I needed. which is right here. If it's just a less than or greater than a less than sign, then the graphed line is going to be a dashed line, and that indicates that the points along the line make the inequality false. So you have to pay attention to whether it's going to be a solid or a dashed line. And then you pick 2 points on either side of the line and figure out which way to shade. Okay, you already know how to plot lines. Now you're just adding an additional layer to it, if you will. Okay, join me on the next page. All right, so this is just more of the same. They went back to the original format of the equation without it in slope-intercept form and put in these 2 points. They originally said, hey, let's use 8, 8. And as you guys could see on the previous page, I used 6, 6. But bottom line, when I do all the math, this one comes out to be a true statement. This one comes out to be a false statement. So I shaded above the line. Okay. Okay, we're going to go to how do we do these if we are going to use a graphing calculator. So that's what we're going to do for explain number 1. So make sure your graphing calculator is handy. All right, so I have several things going on at once. It's kind of a busy screen, but I'm on page 342. And it says to graph the solution set for the given inequality using the method given. And it says to do it with a graphing calculator. So first of all, we've got to take this, and as far as I know, your graphing calculator will not rearrange this to solve for y. So we're still going to do that ourselves. And here's what we get. Now, on your graphing calculator, and you might want to write these down and sketch them in the appropriate area, we need to pick this little triangle that looks like it's pointing up and to the right. If we mean greater than, we're going to pick this little triangle that looks like it's pointing down and to the left if we mean less than. Okay. Other than that, it pretty much is the same as what we've done previously, okay, as far as putting equations into a line. So let me show you what I'm going to do. Okay, I apologize for the size of this image, but I'm over here and I'm going to type in this equation, inequality, into my calculator. So first of all, I'm going to select, yeah, the color, that's fine. Let me see. Hang on just a second. Okay, so the thing is so small that even I'm having a hard time reading it. But it says press the left or right arrow to change my little symbol. So that's what they're talking about. If you notice that this little thing's changing. Okay, but bottom line, this is a greater than situation, so I need this one. There we go. And then I'm going to say, okay. So now it's got the little up and to the right looking arrow, and I can just type in the rest of my inequality. So negative 3x plus 7. I am going to redo my window settings. Negative 10 to 10. Paging. Okay, I'll admit I cheated a little bit. I paused it and I just cleared my memory. And so my window settings are back to what they normally are. I've put in the inequality right here. I've made sure my little triangle is pointed kind of up and to the right because that's going to mean greater than. And then I'm going to go over here and graph. And you see that they draw the line and they shade the appropriate side. Okay. Now, the one thing that the calculator will not do for you is decide whether it's dotted or dashed, or at least I can't tell that they do that. So you still have to know that in this situation, because it says y is greater than and not y is greater than or equal to, that this line will be dashed and points on the line do not make this equation true. Okay. Okay, so just down here, sorry, my little thing's covering up. The screen on here looks a little bit more old-fashioned than my fancy-dancy new one, but you get the same graph, and we're just going to practice these either manually with you plotting and shading yourself or with the help of a graphing calculator, and you have the calculator shade, but you still have to know whether to mentally say that's a dashed line or a solid line. All right?